Surds. When we can't simplify a number to remove a square root, cube root, etc., then it is a surd. Here you see square root of 2. We can't simplify it, so it's a surd. Square root of 3. We cannot simplify it further, so it's a surd. Now you see square root of 4. We can simplify it to 2. So it's not a surd. Square root of 1 by 4. That is 1 divided by 2. So it can be further simplified. So it's not a surd. Cube root of 11. That we cannot further simplify. So it is a surd. Cube root of 27. 3. So it can be further simplified. So it's not a surd. If we represent a surd in decimal form, it will be never ending and never repeating. Let's see the value of square root of 2 in decimal form. In decimal form, square root of 2 is equal to 1.414213 etc. It goes on. It never ends, never repeats. Surds are examples for irrational numbers. Do you remember what irrational numbers are? Irrational numbers are the numbers that cannot be represented in the form a divided by b, where a and b are integers. What are integers? Numbers like -4, -3, -2, -1, 0, 1, 2, 3, etc. So we can say when it is a root and irrational, it is a surd. But not all roots are surds. Surds give exact values for answers to calculations. Here we are trying to simplify surds. For that we have two rules. To manipulate surds we have two rules. Let's see them. The first rule is square root of AB is equal to square root of A times square root of B. Let's see an example. Square root of 9 times 4. According to this rule, it must be square root of 9 times square root of 4. You see, this is square root of 36, which is equal to 6. Now you see, this is square root of 9 is 3 and square root of 4 is 2, again 6. You can check with other numbers and make it sure. Then we have another rule. Square root of A divided by B is equal to square root of A divided by square root of B. Now you see, square root of 16 divided by 4. According to this rule, it must be square root of 16 divided by square root of 4. Let's see. Square root of 16. 16 divided by 4 is 4. So square root of 16 divided by 4 is square root of 4. That's equal to 2. Now we will see. Square root of 16 is how much? 4. Divided by square root of 4, that is 2. 4 divided by 2, that's 2. So you see, the rule works. If you want to check with the other numbers, you can check it. Now you may think there are some other rules also possible. Let's check it. Square root of A plus B. You might think it's square root of A plus square root of B. No, it's not. It's incorrect. Let's check with an example. Square root of 10 plus 10. Then It must be square root of 10 plus square root of 10. You see, this is square root of 20, that is 2 root 5. Now, how much is square root of 10 plus square root of 10? It's 2 root 10. So, these two cannot be equal. So, you see, square root of a plus b is not at all equal to square root of a plus square root of b. These are wrong. Similarly, square root of a minus b you cannot write as square root of a minus square root of b. That also we cannot apply because both are wrong. If you want, you can check with other examples as well for square root of a minus b. Now we are going to simplify surds using the two rules that we have learned to manipulate surds. First one is root of ab is equal to root of a times root of b. Second one is root of a divided by b is equal to root of a divided by root of b. We are solving questions from your textbook itself. The first question is to simplify. Simplify. Question number 1. Square root of 12. So you see square root of 12 you need to simplify. You see you can write 12 as 6 times 2. If you write square root of 12 as square root of 6 times 2. Using this rule we can write as square root of 6 times square root of 2. But it's not useful for us. Square root of 6 cannot be further simplified. Square root of 2 also cannot be further simplified. So that's not helpful for us. So what we can do? We have to look for a factor of 12 that's a square number. A factor of 12 that's a square number. So you see square root of 4 times 3. That works because 4 is a square number. According to the first rule, we can write it as square root of 4 times square root of 3. Square root of 4 is how much? 2. Square root of 3 we cannot further simplify. So it is 2 root 3. Now by any chance if you cannot find the perfect square that is a factor, then you can use this method. See, divide 12 by a prime number or the smallest number possible. So 12 divided by 2, 6. 6 divided by 2, 3. So it's a prime number, there you can stop, we cannot further simplify. Make pairs if possible. You see, we have 2 2's, so we can make a pair there. 3 is single, so we cannot make a pair. From each pair, take one member. So from these 2 2's, take 1 2 and place outside the root. Then the single one keep inside the root. So 2 root 3. By chance, if we cannot find the perfect square factor, you can use this method. Now you see, if you are using a calculator of this type, you don't need to do any work. You can directly input the quantities and get the answer. For example, square root of 12 equals. See, it directly gives you 2 root 3. So no need of any work. You can just write square root of 12 is equal to 2 root 3. Now you see, if you are using a calculator of this type, see square root of 12 is equal to, you are not going to get an exact value but only decimals. So this calculator is not going to help you in simplifying surds. So you have to do it by yourself. So if you haven't bought a calculator yet, buy this kind of calculator. But if you have already bought the other one, you can just use it and work like this. Now you see, we will try another example. square root of 75. We have to simplify. So we have to find a factor of 75, that's a perfect square. So let's write 75 is 25 times 3. You see 25 is a square number. So using the first formula we can write it as square root of 25 times square root of 3. Square root of 25 is 5. Root 3 cannot be further simplified. So it is 5 root 3. If you are using calculator, directly write it. Now if you can't find a perfect square, do the way as I said before. 75. You can divide by 3. You can check it with your calculator, or even 5 is fine. So 3 times 2 is 6. 25. Now we can divide by 5. Now you see, we can make a pair of 5s and 3 is single. So you see, from the pair take one member out and place outside the root. The single one place inside the root. 5 root 3. We will see one more example. Square root of 90. See, we have to make a factor of 90, that's a perfect square. We know that 9 is a perfect square, so you can write it as 9 times 10. So according to the first rule, we can write it as square root of 9 times square root of 10. So this is square root of 9 is 3. Root 10 is not a perfect square, so 3 root 10. Now you can't find the perfect square. 90 can be divided by 2. 45 can be divided by 3. 15 can be divided by again 3. 5. Now you see, you can make a pair of 3 here. 5 and 2 are singles. So from the pair, take one member out and place outside the root. The singles, we have 2 singles, put it inside the root. 5 times 2. So 3 root 10. Let's see another example. Square root of 27 divided by 3. See, 27 can be written as 9 times 3, where 9 is a perfect square. So according to the first rule, we can further simplify it as square root of 9 times square root of 3 divided by 3. So square root of 9 is 3, 3 root 3, because 3 root 3 cannot be further simplified. 3 root 3 divided by 3, 3 and 3 can be cancelled. So answer is root 3. Now if you cannot find the perfect square, you can go with 27 divided by 3, 9 divided by 3. See, you can make a pair here. From here take 1 3 and put outside the bracket. One single 3 is there, keep it outside. Sorry, keep that single 3 inside the square root. Then you are getting square root of 27. Let's see another problem. Square root of 20 plus square root of 80. 20 can be written as square root of 4 times 5, because 4 is a perfect square. and 80 can be written as square root of 16 times 5 because 16 is a perfect square. So we can write it as square root of 4 times square root of 5 according to the first rule, plus square root of 16 times square root of 5. Now you see square root of 4 is 2. So this is 2 root 5. 2 root 5 plus 4 root 5 because square root of 16 is 4 and square root of 5 that cannot be further simplified. 2 root 5 plus 4 root 5. You see root 5 is common here. So put outside the bracket 2 plus 4. So root 5 times 6, that is 6 root 5. Now you see, if you cannot find the perfect square factor for 80, you can try the other method what we learned. 80 divided by 2, 40 divided by 2, 20 divided by 2, divided by 2, 5. Make pairs. Possible pairs are 2 pairs of 2's. From each pair take one member. From this pair take one member, that is 2. From this pair take one member, that is another 2. 2 times 2, the single one place inside the root. So 2 times 2 root 5, that is 4 root 5. This is root 80. Similarly, you can find root 20 also and do the following steps. You see, in this question, only 2 steps are necessary. One is this one. You should show this step for exam. That is for that carries one method mark M1. And this answer you have to write. That is accuracy mark A1. See, all these steps are not necessary. The important steps are this one for method mark and this one for answer mark. If you are using a calculator also, you have to show this step and this one. Directly don't write 6 root 5. Then we will try another question. Square root of 175 plus square root of 63 plus 2 times root 28. 2 times root 28. We have to simplify it. So first 175 we can write as a factor of a square number. We know 175 is 25 times 7. Then 63 is 9 times 7 plus 2 times 28 is 4 times 7. Now we can use this rule. So root of 25 times root of 7 plus root of 9 times root of 7 plus 2 times root of 4 times root of 7. So root 25 is 5 root 7 plus 3 root 7 plus 2 times root 4. Root 4 itself is 2. So 2 times root 4 is 2 times 2. It is a 4. 4 root 7. You see, root 7 is common everywhere. Take that out. Root 7 times 5 plus 3 plus 4. That is root 7 times 12. That is 12 root 7. Very easy, right? So which are the steps that you need to show? You have to show this one, and this one. Let's see another example. Root 80 minus 2 root 20 plus 3 root 45. Root 80 we can write as 16 times 5 minus 2 times root 20 can be written as 5 times 4 plus 3 times root 45 can be written as 9 times 5. So root 16 times root 5 is root 16 times root 5 minus 2 times root 5 times root 4, that is same as root 4 times root 5 plus 3 times root 9 times root 5. Now you see root 16 is 4, so this is 4 root 5. Root 4 is 2, so minus 2 times 2 is minus 4. Then there is a root 5 minus 4 root 5 plus 3 times root 9. Root 9 is 3, so 3 times 3 is 9, 9 root 5. Now you see root 5 is common there. Take outside the bracket. The remaining you can place inside the bracket. 4 minus 4 plus 9. So root 5 times 9, 9 root 5. If you cannot find a perfect square as a factor, you know what you have to do. You can continue by that method. Now we'll be doing a past paper question. Question number 2. Simplify square root of 32 plus square root of 18. Giving your answer in the form A root B, where A and B are integers. See what we need to do? We have to represent root 32 plus root 18 in the form A root B, where A and B are integers. So what we can do? We can simplify root 32 plus root 18. Root 32 plus root 18. Root 32 we can write as a factor of a square number, that is 16 times 2. Then root 18 we can write as a factor of a square number, that is 9 times 2. Now see this, according to the first rule, we can rewrite as root of 16 times root of 2 plus root of 9 times root of 2. Root 16 is 4, 4 root 2 plus root 9 is 3, 3 root 2. When we take root 2 out, it will be root 2 times 4 plus 3, that is 7 root 2. See, this question carries 2 marks. So 1 method mark and 1 answer mark. So what is it? These all steps are unnecessary. For exam, the compulsory steps are this one for getting method mark, and this one answer, that is for getting accuracy mark. Here is your homework for the next day. The second question is a past paper question. All the best with the homework.